So today we are going to talk about word problems involving consecutive even and odd integers. So previously we've learned about just regular consecutive integers such as the numbers 4, 5, and 6. And we represented those numbers with variables and expressions. The first number was always represented by x. And then we said, okay, how do we get from the first number to the second number? Well, we add 1 since they are consecutive. So to get from x to the next number, we take it and we add 1. And then we have our third consecutive number, which in this case was 6. And I know to get from 4 to 6, I have to add 2. Well, to get from x to the third number, I take it and I add 2. And this is for just regular consecutive integers. But today we're going to go a step further and talk about consecutive even and odds. So again, consecutive numbers are numbers that appear in order, but even consecutive numbers appear in order, one after the other. So even examples would be 2, 4, 6. They are even numbers and they appear one right after the other. So you can see the examples below are also examples of consecutive even integers. Consecutive odd integers again appear in order, one after the other. So you can see that 3, 5, and 7 are odd numbers. -7, -9, and 11 are odd numbers that appear in order. So even and odd numbers need to be represented a little bit differently than regular consecutive integers. So if I take the odd number example of 3, 5, and 7. Those are 3 consecutive odd integers. Like always, I will represent my first integer with the letter x. That does not change. But then I have to ask myself, how do I get from my first odd number to my second odd number? And you should be able to see that you add 2. So in order to write my second odd integer algebraically, I take the first number and add 2. So this is where it starts to get just a little bit different from just regular old consecutive integers. And then I need to be able to represent my third consecutive odd number. So I say, well, how do I get from my first number, 3, to 7? And you should be able to figure out that we would add 4. So to represent any odd consecutive numbers, I have x plus 2, and x plus 4, instead of what we were doing originally with just regular consecutive numbers. So what happens if they're even? So if I take the example 2, 4, and 6, I can proceed the same way. I know that I can represent my first number 2 with the letter x, and then I say, how do I get from 2 to 4? Well, I add 2. So to get my second consecutive even number, I take x and I add 2. How do I get to my third consecutive even number? Well, I go for my first integer and I add, in this case again, is 4. So I represent this as x plus 4, and this is how I would represent 3 even integers, consecutive. So if you notice, they're the same. And that's okay. We are always skipping by 2 anytime I go from one consecutive even or odd number to the next. So if you look at the notes up here, the first number is always represented by x when we are dealing with even or odd or regular integers. But when I'm dealing with even and odd numbers, my second number is always represented by x plus 2 this time. And again, with even and odd numbers, my third number is represented by x plus 4. And if I were to continue, I would actually have x plus 6. So it doesn't matter that these numbers are even. This is how you would represent even or odd numbers, always. So if we take a look, example 1 says find two consecutive even integers whose sum is 126. We know that x is the first, in this case, even integer. Obviously, if it were odd, we would write the word odd there. And then my second even integer is always represented by x plus 2. So I have x and x plus 2. And it says find two consecutive even integers whose sum, we know means plus, is 126. So I take x, which is my first number, and I add it to x plus 2, which represents my second number, and I set it equal to 126. I combine like terms, I subtract 2, I get 124, and then I divide by 2, and I get x equals 62. And then I go over here and I know that if x is 62, then x plus 2 has to be 64. And a good way to check yourself is to say, oh, do I have even numbers? Yes, I do. I needed them both to be even, and they are. So again, let's say we had some odd numbers here, and that's okay. It does the same way. So here we have the sum of 3 consecutive odd integers is negative 219. Find the integers. We know x is our first odd integer. Our second odd integer is always represented by x plus 2, just like even numbers are represented. And then my third odd integer is represented always by x plus 4. So then it tells me to find the sum. The sum is negative 219. So I'm going to add all three of these integers. So I have x plus 1 plus x, I'm sorry, that should be an x plus 2, and x plus 4. So now I combine my like terms. I have 3x plus 6 equals negative 219. So I have 3x equals, now if I were to add negative 219 and negative 6, we become 15, 5, negative 225. I divide by 3, and we get that x is equal to negative 7, I'm doing my long division here, 3 goes into 22 7 times, with 1 left over, 75. Now here is the tricky part with negative numbers. I know that my next integer is x plus 2. If I were to look at the number line, I have negative 75, negative 74, negative 76. If I'm here and I'm adding 2, I'm going to move to the right 2. So this would actually be negative 73. And then I'm adding another 2, or I'm adding 4 actually. So 3, that would be negative 72. 4, that would be negative 71. So that's just the trickiest part with negatives, is knowing how to add properly. But otherwise, it's the same thing as regular consecutive integers. The only thing that's different is right here, the numbers you add by, which are always plus 2 and plus 4. Complete the Did You Get It? And be ready for tomorrow.
I don't know how to stop.